This is an alternate method to solving a limiting reactant problem. It's a little bit shorter and it's a little bit less tedious. However, there are some conceptual things that need to occur in order to truly understand how to solve a problem this way. I'll show you how to do a problem using this alternate method. So the first thing we would want to do is take our grams of each of our reactants and convert them into moles. So I'll take my 225 grams of PCl3, multiply by 1 mole, over the molar mass of PCl3, which is 137.32 grams. Make sure my units cross out, and I have 1.64 moles of PCl3. Now I'm going to do the exact same thing for my other reactant, which is water. So 123 grams of water, multiply by 1 mole, over the molar mass of water, which is 18 grams per mole. Make sure my units cross out. And I have 6.83 moles of water. Now what I can do is I can carefully look at these numbers and I can compare them to the mole ratio from the balanced equation. So it looks like for every 1 PCl3, 3 waters are needed in order to fully react. So I can look to see, does this 1 to 3 ratio apply with these amounts of moles that I have? Sometimes you can do a little bit of mental math. Like you might realize that 1.64 moles times 3 is actually less than 6.83 moles. Another thing that you can do is you can actually multiply by the mole ratio to actually see whether or not you have enough. Let's look at PCl3 for example. So if I were to use all 1.64 moles of PCl3, how many moles of water would I have to go with it? Well, 3 waters for every 1 PCl3. So let's multiply by a 3-to-1 ratio. What that gives me is 4.92 moles of water are needed. Now what I do is I look to see if I actually have enough water. And guess what? I do. I have 6.83 moles of water. So there's plenty of water that I could use if I use all of the PCl3. What that tells me is that PCl3 is my limiting reactant. If I use all of the 1.64 moles of PCl3, I can then also use 4.92 moles of water, and then I will have some excess water left over. So this is an alternate way of identifying the limiting reactant without having to go through 2 scenarios. Now what I would then do is after I've identified my limiting reactant, I will base all of my calculations on the limiting reactant. So I'll cross out any information that I know is not helpful to me, and then I will continue the problem knowing that 1.64 moles of PCl3 will fully react, and then I will continue the problem from there. Now I'm still looking at theoretical yield, so I still focus on my product, okay? There's 1 mole of H3PO3 for every 1 mole of PCl3. It's a 1-to-1 ratio, so I don't even really need to show my work there. 1.64 moles of phosphorus acid will form from all of the PCl3 reacting, and my last step would be to simply convert it into grams. Molar mass of H3PO3 is, let's see, 82 grams per mole. Again, just confirm that the units are crossing out. And I should have my theoretical yield, which is 134 grams of H3PO3. So this is a faster way to get the answer to a limiting reactant problem without having to go through both scenarios.